Okay, so we are doing the College Algebra 7.3 Systems of Nonlinear Equations and Inequalities, looking at just two variables. And so we have a couple different examples that we're going to talk about. The first one is, what if we have a parabola and a line, and we have three different options. The first option is they never meet, which means there's no solution. One option is that they intersect only once, and then there's an option where they intersect twice. There is not an infinite solutions because obviously a line only has one slope, and the parabola curves. So depending upon how we want to do this, I typically like to do substitution. So I'm going to take my first equation, make this x equals, I'm going to add y to both sides, y minus 1. Now I'm going to substitute, put this in there, so it's going to give me y is equal to y minus 1 squared plus 1. And so we're just determining, is this 1, 2 solutions, no solutions. So now we need to go ahead and solve for y. So we need to factor this out, we need to multiply this out. This becomes y squared minus 2y plus 1. And now what we're going to do is we're going to combine like terms, which would give us y squared minus 2y plus 2. And since we now have a quadratic, we need to set it equal to 0. Right? That's how we solve quadratics. So I'm going to subtract y from both sides. And this is going to give me 0 equals y squared minus 3y plus 2. Now we need a factor. And we say, what are our factors of 2 that when I add them together give me negative 3? Well, that's going to be y minus 1 and y minus 2. So two of our solutions, we're going to have two solutions where y is 1 and y is also 2. But now I need to stick these into an equation. And I don't want to deal with x squared, so we're going to stick them into this equation. We're going to say x minus 1 equals negative 1, and x minus 2 equals negative 1, and solve. So x is equal to 0, and x is equal to 1. So our solutions are 0, 1, and 1, 2. So this shows that in this case, this linear function, this line, intersects this parabola twice. Then we go to an instance where we have a line and we have a circle. Now, just realize that, again, we have the same idea. We have no solutions, one solution, or two solutions. And this is already set up for it. We're going to substitute. We're going to take this, and we're going to put it right in there. So that gives us x squared plus 3x minus 5 squared equals 5. So this is x squared. This becomes 9x squared. That's here. 3 times negative 5 is negative 15. We double it. That gives us negative 30x. And then we do negative 5 twice squared, and that makes it 25. And now we're going to combine like terms. So this gives us 10x squared minus 30x. Now I'm going to also subtract 5 from both sides to make this equal to 0. So it gives us plus 20 equals 0. Hopefully we can, we always want to see if we can do a greatest common factor. In this case we can. We can actually divide everything by 10, which gives us x squared minus 3x plus 2 equals 0. Well, this is kind of nice. We just saw this in the previous problem. So that means that x is going to either equal 1 or 2, because this factors as x minus 1 and x minus 2. So now once I have my x, I'm going to stick these into this equation. It's my second one, so I'm going to say 3 times 1 minus 5. So 3 times 1 is 3, minus 5 is negative 2. And then I want to say, okay, what about 2? So 3 times 2 minus 5, so 3 times 2 is 6, minus 1 is 1. So this tells me my answers are 1 and negative 2, and 2, 1. Right, so this kind of puts everything in together about, we need to know how to set up, so we're using 7.2 and 7.1 substitution in there. And then we're also using our previous exercises in going back to chapter 4 and chapter 5, where we're doing quadratics, we're simplifying quadratics, and we're solving them. Right. Next thing, what if we have two circles? So two circles, again, we have no solution, one solution, two solutions, three solutions, four solutions, and I would even state in there could be, I won't say an infinite amount of solutions, but there will be almost like all solutions, because you could technically have a circle and they're just the same in just different forms. So it's a tad bit more difficult. We need to try to solve for something. So let's do this. How about we solve for x? Let's see, what should we do? Should we solve for x or should we solve for y? Unless we can make 26 100, which we can't. Let me see here. Oh, we could do. Oh, right. What we can actually do is we can do, instead of substitution, let's talk about canceling. So could we not multiply this top one by negative 3? That would give us negative 3x squared minus 3y squared, and 26 times 3 would be negative 78. And then I want to add these together, and that'll actually give me 22y squared equals 22. Well, that's quite nice, because we can solve this. Let's divide both sides by 22, which means y squared is equal to 1. Take the square root of both sides. That means y is equal to a plus or minus 1. But now we need to go back and we need to solve. So let's take. I'm going to take the first one. Don't have to deal with extra numbers, I don't want to. So I have x squared plus 1 squared equals 26. It's going to give me x squared plus 1 equals 26, and x, so we would subtract 1 from both sides, give us x squared equals 25, and we take the square root of that. X is equal to a positive or a negative 5. Okay, so then we're also going to do for negative 1. So negative 1, if we do, so we do x squared, let me see here, ran out of room. Let's do this. Let's do this. So x squared plus a negative 1 squared equals 26. What's interesting is negative 1 squared gets us back to the original problem. So we have x plus or minus 5 again. So what does that mean? So how many solutions do we have for this? Well, in this case, we could actually have up to 4 possible answers. Right? So we could have, if we have a 5, comma 1, negative 5, comma 1, and we have a 5, negative 1, and 5, positive 1. We have 4 possible solutions for this. Alright, now we're going to graph this. So x squared plus 1. Well, this is kind of this is not the greatest graph that we could do, but so if we can't tell what our vertex is, our vertex in this case is 0, 1. If you don't remember how to get that, you know that this doesn't shift up, down, left, or right. So we're right here, and we go up 1, so we know it goes right here. We know it is also a parabola, so it shifts up, and it looks something like this. And we're going to say y is greater than, so that means it's up here. Now, what I did not draw correctly is that this is supposed to be a dotted line because it does not have the equals to it. And we shade in everything up here. And our last problem is that we are now going to do a parabola and a linear line, and we're going to do an inequality with it. Now let's just remember something. Nothing changes when we solve this. So what I want to do is I want to graph these first. That's what I want to do. So let's see here, x squared minus 1. So I know that this is an x plus 1 and an x minus 1. Let me see if I can. So I know for my parabola we have the x-intercepts right here, my y-intercept and vertex are both right there, and in this case I would just very gingerly draw, well, if my tablet would work, just something like that. That's very ugly. Then I would do this one. So let's see here. We want to make this y equal. So let's move the y over here and the negative 1 over there. That gives me x plus 1 is greater than or equal to y. We could flip that around, say y is less than or equal to x plus 1. So our line is, my y-intercept is 1 right here, and I have a slope of 1 over 1. So my line looks something like that. So if we're just graphing this, and I want to know kind of what the set is, I mean, it'd be nice. I'd love to actually figure out what these are, but in this case, y is, I need to pick a point. So I'm going to pick a point 0, 0 first. And I want to see if it's a solution for them. So I want to say, is 0 greater than or equal to 0 squared minus 1? And in this case, 0 is greater than negative 1. So I know that up here in our inequality that I'm looking inside of it. I'm looking inside of my inequality. Now I'm going to do the same thing with my line. I want to say is 0 plus 1 greater than or equal to 0. Or you can put up here, you can say is 0 minus 0 greater than or equal to negative 1 if I want to use my original point. And yes, 0 is greater than or equal to negative 1. So that means that everything below my line is a possible answer for that one. And if you remember doing this with different types of inequalities, the point where they both overlap, which is right here, this is our solution set. And that is what I'm looking for. Now, just realize it might ask you where they intersect,
and again, you just do what we did in this one right here. You find out where they intersect. You set them, make them equal, not inequalities, and then you can give me the points to where they do. Fairly simple, I think. That is 7.3.